So I would like to introduce Professor Prithvi Singh Kandhal, who is currently the Associate Director of the NCAT, which is National Center for Asphalt Technology, which is based in US. And NCAT, if you were to be precise, is the largest asphalt road technology center in the world. And prior to NCAT, he has served as the Chief Asphalt Road Engineer of the Pennsylvania Department of Transportation for 17 years. And he has served as a President, International Association of Asphalt Paving Technology, and also as the Chairman, American Society for Testing and Materials International Committee on Road Paving Standards, and Chairman, US Transportation Research Board Committee on Asphalt Roads. And also recently he has developed new standards for IRC, which is Indian Road Congress. He has also got a Lifetime Achievement Award in Asphalt Road Technology from the International Association of Asphalt Paving Technologists during the annual banquet held in Austin, which is at US. We have invited him personally here because based on the requirements that we have received from the site, wherein they wanted to learn more about the advancement in the construction technologies and how advancement in the construction technologies and also about the maintenance. So over to you, sir. So you can actually highlight.
Thank you very much.
Thank you.
Okay, now that we have the mix produced in a hot mix plant, whether it's a batch or dry drum plant, we have to lay down, send the mix to the project site and lay it down. When I say lay down means laying down with the paver. That's what the paving operation we are going to talk about, and field inspection. So here is a typical paving operation going on, that's in the US. And the topics we are going to discuss is that first we have to prepare the surface, then the asphalt mix has to be delivery, how it's going to be delivered. Then we discuss very briefly about the paving equipment, paving procedures, then mix and mat inspection, and constructing joints. These are the things we are going to cover in the paving. First of all, you can see here that we have to clean the existing pavement. If I have, let's say this is DBM, I'm trying to prepare for BC, and if I don't clean and there is a layer of mud on that, and I lay BC on the layer of mud, what will happen? What will happen? Huh? Yeah, it won't stick there, And when I design the pavement, I assume that BC and DBM are just one slab. If I got a mud layer, if I don't apply any Tack Coat, the pavement will think that it's only 40 millimeter thick, like your BC, and you will have fatigue cracking. So we got to clean that out real good before you apply the Tack Coat, and then we got to apply a Tack Coat to promote the bonding between the asphalt layers. That's a must, Tack Coat should be uniform. Tack Coat should not be excessive and would cause slippage. Some of our NHI inspector, think that too much is good, They think that the contractor is not putting enough Tack Coat, so they will tell, no, just go one more time and all that. They don't understand that can cause some slippage. You might have seen some moon-shaped slippage cracks, and that will happen because of that. So here you can see on the left side, you see the Tack Coat is being applied with a distributor with all the spray bar and nozzles, and on the right side you see the bitumen distributor, the whole operation. You see the Tack Coat is being applied, and this is a good example of a non-uniform Tack Coat. Tack Coat should cover the whole surface, and we use the slow setting emulsion. Not the rapid setting emulsion in India. In the US they use slow setting dilute with water, but we use rapid setting RS grade emulsion. But still we should not have this kind of non-uniform Tack Coat. Here is a good example of a uniform Tack Coat, and again it should not be too excessive. Too much is bad. And then we have the asphalt mix delivery. We'll talk about after Tack Coat, we'll talk about how the asphalt is delivered. Well, first of all, yeah, go ahead. Yeah, the question is there is no Tack Coat. I think there is something here like some sort of a stress bearing layer or something, stress absorbing layer where you put aggregate as a interlayer to resist the reflection and cracking. Yeah.
Practically one problem I have seen is after laying the tack coat,
Hmm.
the trucks will ply on the tack coat.
Hmm.
So maybe 2-3 trucks will ply at least.
Hmm.
After plying, the tack coat is taken away by the truck.
Hmm.
So how
Well-
to address that?
Well, that has been the question here is that when you apply a tack coat, then the trucks, the tires will stick. It will stick to the truck tires, and some of it will be taken away. That has been a problem for so many years now. But since we don't need too much tack coat, tires sometimes even maybe distribute better or something, so it has not caused any problem. It looks like a problem, but it does not cause some will be carried away by the truck tires. But if you apply uniform, it still covered the whole surface. It has not given any problem. But in the last few years, there is a new tack coat material which has come in the US, and that's not picked up by the tires at all. It's called non-stick or something. There is a tack coat material available in the US, non-stick tack coat, and hopefully that will also come in India. So that is affected by trucks. So that's a good point. It's always been a problem. And you got a keen eye. You saw the tack coat here. I never saw this slide. But since I know about the stress relief layer, so I could answer that. Otherwise, I will be in trouble. Now, diesel fuel we should not apply because we have to apply the so-called asphalt release agent to the bed of the truck. So the mix does not stick to the truck bed or the sides. So we have to apply the so-called asphalt release agent to the body of the truck. And in the past we were using diesel, which is not good enough because the diesel can dissolve the bitumen. So we got to use some commercial type of release agents are available now. There will be like a soap water or some emulsions, are available, which they don't affect the bituminous concrete or asphalt concrete, which don't dissolve the bitumen. Those are the ones which should be used. But diesel fuel cannot be used, and I know it's still being used in India. This is how do we load a truck? The truck is parked below the pug mill, so either we can have one drop, which is not good. It's called segregation. When we have one load, big load, just only one pile on the truck, that's incorrect, because the coarser particle will slide off and be at the edge on the bottom of this pile, and we'll have segregation. When we are paving, some spots won't have enough fines. So to prevent that, we have to have 3 drops. So that means the truck has to move back and forth. Drop number 1, then drop number 2 at the back end of the truck, and number 3 in the middle. That's the way to minimize the segregation. But I know people don't do it. Because the truck driver has to go left. They do? Is that right? That's good. They will do? Okay, then you guys are doing good control, Yeah. So that's the correct way to do it. Discharge that way, there won't be any segregation problem. So here we are showing that it's a good practice always to put a tarpaulin on the top of the mix, so the mix doesn't cool down, especially in the winter time. So tarping the load is very important. We should also check the mix temperature. Some of the trucks have a hole in which you can test the mix temperature. And then here's the tipping truck, tipping the mix in the paver on the right side. And this is just a cartoon, These are the old cartoons I got from the US when they were doing training like 30 years ago, Just like as a joke, this. Like the truck is going to the paver at a speed, so it just, so it should go to the paver very, very slowly. And here the proper unloading is being done. just a picture of the tipping truck. Now, one thing which is in US, which is required on the national highways in the US, is to have a material transfer vehicle, the so-called MTV. Because what happens is that if I'm paving and there is no truck, so the paver has to stop. Whenever it stops, it makes a bump there, it kind of sinks a little bit there, and then you start paving along. So your riding quality is affected. So what they do in the US is that they use this material transfer vehicle, which is being fed on the left side. You can see the truck feeding this road tech MTV, they call it MTV. This MTV has a capacity of 25 to 30 tons. So this is always filled, always filled with hot mix. And so the paver is supplied to the paver hopper, so the paver keeps on going. So it's more like a moving storage silo. So it's a requirement on many of the national highways in the US that on this project you have to have an MTV. So that's a requirement to get a good riding quality. I know the paver driver would like that because he cannot have coffee break. He just have to keep on moving all the time. But this is in the US called MTV, material transfer vehicle. We don't have it in India as yet. Here is a MTV in operation. You can see here on the right side the truck is putting the mix in the MTV, which is in the white equipment in the middle, and the left side you have the paver, where the MTV is feeding the paver. So the operation just keeps on going, gives you very good riding quality. Huh?
Sir, but when you say that the MTV is required to avoid the stoppage of paver, but in this photograph it seems that carriageway is not paved with a single pave, again that will develop a continuous joint.
No, I didn't. The joint we make at the end of the day is the transverse joint.
No, this longitudinal joint is possible.
Yeah, longitudinal joint. What you are doing is that maybe you are paving like for 2 or 3 kilometers, and then you move around and pave the other lane. So the so-called warm joint, it's not a hard joint. By the time mix has cooled somewhat, so it's called warm joint. That's what we do in here. So I think you are asking that we cannot keep on paving for a long time. We just pave for 2 or 3 kilometers, with the MTV, and then we turn around just like we do. So we are not going to change that operation because to get the warm joint. Does that answer your question? Or?
I was asking if they are so much particular that
Stopping.
bumps should not be there. In this also it will create a longitudinal complete line only.
No, I'm talking about the bump like in the profile. When you are paving, when you stop the paver, it kind of a little bit sinks. It creates a dip there, and then when you resume paving, so that dip is still there. So in the longitudinal profile of that lane, you got dips. Yeah, so we are trying to avoid those dips. So the paving equipment, we are talking about the paver now. Is a typical paver. On the right side we see the truck and the paving machine on the left side. And here is the schematic of the paver. Starting from the left side we have a hopper where the truck will put in there, and it's a tractor. It's a like what you call self-propelled equipment. It moves by its own, and then at the bottom we have a toe point, and at the right side we have a screed. You can see the screed is a free floating type mechanism. It has a toe point where this can go up and down. The toe point is right here as marked, and screed will go up and down, and there is the depth crank, you see like a wheel handle. The person keeps on moving that, to control the depth of the layer. And here is how the material will flow. From the left side you have the hopper wings, and there is a slat conveyor, there is a hopper gate, and on the back, on the right side you have augers, and you have the screed plate. But I'll show you a better picture in this one here. This one you have a hopper, where the hot mixes will be placed by the truck, and in the middle you see conveyor. This is conveying the mix to the back of the paver. This is the front. So the paver is coming towards us, you know. So mix is being conveyed with this sled conveyor, and there is a hopper gate here. I can control the height of the hopper gate to control the flow of the material which is going back. And then these are the hopper wings, you know. Then after the end of the day, I can fold these wings, and then the remaining material will be used, you know. But it's not a good practice. Sometimes what happens is that after every truck load, if no truck is coming, the paver operator will just fold these, and the material will go in the back and go on the road. What happens is that near these hopper wings, there is always a coarser material is collected here. So when I drop the wings, you know, then at the end of each truck load, you will see coarser mix, you know, in a V shape. And so the best thing is not to drop it at all. Let it accumulate for the whole day, and then at the end of the day, you know, you just waste it or do whatever. So that's a big problem here. So here you can see the conveyor is taking it to the back, and there is a gate, and here the auger on the back which will spread the mix, you know, across the whole entire width. Whatever we have, 4 meter or whatever, the auger will spread it out. So here in this picture, the main thing is that again we can see the screed, and it's free floating. There is a toe point here. This mix is free floating. The mix is here. This is, but it's more clear in the next slide that here we got 3 situations here. On the top, the mix is of sufficient amount, so it's maintaining the correct depth. Like if I need 40 millimeter BC, I have to have a right amount of mix, you know, in front of my this screed, so I get 40 millimeter. If the head of the material volume is too high, then that will cause this one to raise, and the screed will raise, and then excess material will be coming out of that. At the bottom, if the head of material volume is too low, then I would have inadequate material in the back. So the top situation is the best, you know, and that's what that crank control we see. That guy, you know, is operating the crank control. You know, he's regulating the speed. That's what he's doing. He's trying to control the material which is in front of the screen. But you shouldn't do that too much, you know. Sometimes they just keep on changing. You know, they react too fast, because once they do it, you know, it takes some time before you get to the desired depth.
At this stage, sometimes most of segregation happens at this stage only. Why it is?
Yeah, most of the time happens because of the truck to truck load, or how its mix is being fed into the paver. There's a lot of segregation takes place in here also, beside the loading of the truck. Here shows the balancing of production. When I'm doing a paving, I have to balance out like how much mix I am producing. On the left side, you see the asphalt plant and trucking. How many trucks I have? What's my hot mix plant capacity? That has to match with my paving operation and compaction. How many rollers I have? They both have to be matched, you know. If I have less number of trucks, you know, then I have a problem. Paver has to stop. If I got too many trucks, you know, then they will just wait. So here's another picture of that. So these are the mixed deficiencies. As an inspector, we have to wash out these things. You know, if I see a blue smoke coming out of the truck, that means the mix is overheated. If I'm looking for 150 degrees Celsius, it might be 180, 200, you know. So blue smoke will indicate overheating of mix. Stiffness. Sometimes the mix might be stiff, you know, when the truck is discharging the mix to the paver, it's not flowing real good, or some of the mix will kind of just stay there, which is very stiff. And that will show like low binder content, low bitumen content, or low temperature. slumping. Sometimes I see that in the truck, the mix is not supposed to be level, perfectly level, but sometimes it's just level. It's like it has slumped, it's like level a concrete. So that means there's a high moisture content. We did not dry the aggregate well, so there's higher moisture content in the mix or higher binder content. These will cause the slump. So if there's some slump, you just stop the work, find out what's happening. Bleeding happens sometimes right away, so higher binder content. If the mix has a lean and dull look, it's not shiny, very dull, it could be low binder content, excessive fines, or burnt mix. So if you see that kind of thing, you got to stop the paving and find out what's causing this dull look. If the steam is coming out, then we high moisture content.
Dull look means how it's
Normally, like it's very shiny, mix is black and shiny. No, it's not shiny, it's like dull. Yeah, that kind of thing. So either you got too many fines, which will the fines combined with the bitumen make it a mortar. So the mortar will become dull. If you got too many fines, you got instead of 5%, you got like 10% fines. It will look dull. The shine you see is a combination of fines and the bitumen. There's a mortar. About placing procedure, we have to see that there is no segregation. It's a uniform. We got to see the temperature is okay. These days we have that infrared gun. People keep that gun, to monitor the temperature of the mix behind the paver. Surface appearance of the mat should be good, and pavement geometrics should be okay. Whether you have the right, the curve, you have the super elevation and all that, you got to see that. Causes of segregation, production, storage, loading and transportation, material transfer and laydown, and non-uniformity of mix temperature. What we have seen here is that sometimes the mix, there is a segregation which is called temperature segregation. Now here is a infrared picture of a loose mix behind the paver. Somebody took a picture with the infrared camera, and these different colors will indicate different temperatures. Like spot number 3 had a temperature of 94 degrees Celsius, and spot I don't know what those are. I think these are Fahrenheit 282. In the bracket, I don't know whether that's 94 is Celsius or what. Yeah, should be Celsius. Yeah, on the left side you can see. On the left side you can see the scale of the color, different color and what temperature is there. So this is called temperature segregation. If you have a particular material which is cold, that becomes stiff, The other high temperature will be smooth flowing, and that can cause a problem. Then we also take the, I think this is the measurement for the depth, I think. Surface appearance, texture deficiency, there should not be any tearing and scuffing, there should not be any cracking, fine cracks. Smoothness can be like dips, paver standing on one place, ripples. These kind of things we got to watch out. We got to watch out the thickness, grade of the road, alignment, crown. Here is, I think, like a dipstick to measure the depth of the loose mix behind the paver. Now we go to the constructing joint. We have two types of joint, transverse and longitudinal. Transverse is at the end of the day, we have to make a transverse joint so that we can resume the paving next day. So here the way we make transverse joint is two ways we can make it. One is the bulkhead transverse joint. So in that I just put a lumber, which is a wood lumber here, and then make a ramp here. So next day when I come, I just remove the lumber. So that gives me a vertical. At the bottom I'll get a vertical face, and I remove the ramp. So then I can start the new mat on the following day with the same thickness. So that one way to make a transverse joint. The another way is a paper transverse joint, where I don't use a lumber or wood. I just use this paper in a slope like that, make a ramp so the traffic can still use it without any bump. Next day I just remove the ramp and remove the paper, so that give me like a good face. It's not vertical, but it's like 45 degrees, you know, good clean face there. The next day when I pave in the direction, I make sure that the transverse joint is real good without any bump. So I use a straight edge to check that out.
So which joint is the best? The joint should be in trapezoidal shape or it is a vertical shape?
Well, here you can see that both are acceptable. It's not be jagged type, you know, jagged. It should be clean cut, you know, either vertical or like that 45 degrees or whatever angle. So it's not like jagged, you know, just leave it like that, you know. And next day when you still have to make a ramp. So when you remove the ramp next day, what do? It's very difficult to remove that ramp get a good clean face unless you take a saw. I don't know what the practice is in India. Can anybody comment how do you make the transverse joint? Straight cut. Then we talk about the longitudinal joint, and the best way to make a longitudinal joint is to get a hard joint. You know, you are concerned about that. That's the best way to do it, and that's all can only be possible if you pave in echelon. That means you see the two pavers going side by side, and mix is hard on both of them. So I just get a hard joint like a welding. You know, it's no problem. It will give me a hard joint, and you won't be able to see the joint. You know, at all. This kind of paving is very much prevalent in the airfield runway operation, because in the runway on the highways we don't have much of a problem on the longitudinal joint. We have some. We got 2 lanes. You know, for 2 lanes you can use a wide paver. If you got 3 lanes, then you have a problem. But in the airfield, typically the runway width is like 150 feet. So you got to have many longitudinal joint, and you have to make a good longitudinal joint, because you cannot afford bad joint, because if material start to come out at a joint, it can be sucked in the jet engine and ruin the jet engine right away. You see this, even a bird goes inside the jet engine, you know, the jet engine is gone. So even a small stone will come, you know, in there. So this thing is very common in the airfield construction, and then there are also other ways which are shown to you. Echelon means, you know, side by side. That's an English word for paving, like an echelon, like side by side or close to each other. I don't know what the exact meaning is, but it's called paving. Echelon means 2 pavers, you know, or you can also have 3 pavers if you want. The only thing is that you have to supply the 3 pavers. You know, you have to use like 2 hard mix plant or whatever.
So here the layer.
Okay, here just a typical, you know, we have paved the lane on the left side, and we are paving on the right side of the lane. So we are getting sort of a warm joint here, because you have to do it in the same day. You know, then you call it warm. Although I don't think it's still warm. Sometimes it can become cold depending upon the weather. So the main thing which this slide is showing is that on the right side we have a compacted mat. On the left side we have a uncompacted mat which is loose. So we have to have an overlap between the two, and here it's showing the overlap of like 1 to 1.5 inch or 25 to 40 millimeter. That overlap is there. Don't go more than that. Here sometimes they have too much overlap. So that will be ideal overlap. Now once we get that overlap, then we have to bump back that overlap, you know, to make a, like you see the round side material. You have to use a lute, what they call lute, that thing, you know, with the handle, long handle, and it says like this thing, you know. So you push it back. You should just push it back, which is just right on the joint, because here we have a low density zone. When we compact this mat here on the right side, the edge was not compacted that good, you know, because it was unconfined. So mix kind of pushed out, you know. So if I have enough more material here and then I press it down, it will all go in here because I got a low density zone. Now what they do in India all the time, and I prevent that, is that they don't bump back just here, they bump back all the way, you know. Which is called broadcasting. They just shoot. It goes farther away. In fact, it creates a lot of courses aggregate. And the idea here is I need to have extra material right on the joint. That idea is gone. They just do it that way. And sometimes they do it so much, you know, that it makes a dip there. So this we have to be very much particular about this bumping back. You just bump back enough, you know, to get the extra material right on the edge. If you go beyond that, you are defeating the purpose. So this one you must implement on your project. Now uncompacted mat is always more thickness in compacted mat. Usually it will be like 20% more thickness. So if you are looking for 40 millimeter compacted thickness, then 20% more of that will be how much?
48.
48. So you got to have 48 millimeter loose thickness to get that kind of thing. But this bumping back, now here is a pavement edge cutting. If I am building an airfield, you know, then on the right side I paved it real good, and I know that there is a low density zone here. So in the airfield they use a cutting edge and to make it vertical, and they discard 2 or 3 inches of the material which was low density. With the airfield they really want to have good density on both sides and good longitudinal. There is one more like a called tapered longitudinal joint which is used in the US. This one, the lane on the left side was paved first, and in the screed they have some sort of arrangement, so you got a vertical drop off and then a slope of 1:12, and then when you pave this one there is an overlap here. So here we got not a vertical thing, we got overlap of wedging, so the longitudinal joint doesn't show up, you know. So that's another technique. This is not difficult. When you have screed, you put a steel plate in the screed which will make that shape. Just the last slide to just show you what kind of equipment we had 100 years ago in the US to apply the Tack Coat. And here is you see here there was no paver at that time. So people are spreading the hot mix by hand.